Hello guys and welcome back. So in this video I wanted to talk about the geometry preparation and what kind of details we need for the destruction to look interesting. And let's say we wanted to do a concrete wall and I have this geometry now. When we fracture this, when we divide it into multiple pieces and have, let's say, a sphere or a sphere hitting this, it's gonna basically push the pieces and they will fall down. In real life, if we take a look at a concrete surface, it's not just this, it has a lot of details underneath. So for example, you can have a wood structure, it will have a thin layer of concrete, for example. It will have some wood structure between the concrete and the bricks, and it will have a brick layer, and then behind that there is also another wood structure, for example. This is just to exaggerate stuff, but if you build all these interior surfaces, which is 80% of the destruction visual, because what we like to see is not just the behavior, we like to see the revealing of details that are not visible by default. Because when you look at destructions where you don't see this behavior, it feels missing a lot of visual elements that are very, very important. It depends on the structure that you have. You have to model everything correctly so that when you fracture this, you reveal the correct details. Now I'm gonna try and do this. So let's create a grid. Let's do this. Blast this. I'm gonna add bricks here, so let's do divide. I'm going to divide this, and I only need division along the height. And this is a simple way of brickifying any geometry, basically. So let's say we have 0.25, cool. And then I'm going to group everything. Let's take a look at the primitive numbers. Cool. So 0, 1, 2, 3. I'm going to group by expression. Group by range. And I want to group every two primitives. Cool. So I'm gonna remove those. And delete non-selected. And then I'm going to divide this guy again. But this time I don't need any height division. So let's say 1,000 there. And then here, this is good. I'm going to copy this node. I'm going to offset it to 0.5. Now if we merge these two together, we get bricks. It's missing here, but it's fine. So let's say we extrude this to give them volume. And I'm going to add a small offset, so there is a tiny bit of gap between these guys. And it's always good to have a very, very small gap between the pieces. It's not required, but if you can afford and do that, I think that helps a lot. So here the pieces are not separate, so I'm going to put down a facet node and uniquify each one of them so that the primitive works correctly. Something like that. Okay, so now we have the brick, and I'm gonna take this this again. I'm gonna extrude it. Pardon me. And let's make sure we take on output back, so the back is filled. And here I'm gonna make it 0.1. Something like that, and this is 0.25. Cool. And now we have the front. Take on output back, and let's merge this, and this is going to be the concrete around the bricks. Okay, right now it's overlapping, so let's transform it there. I'm gonna add a space because I want to add something in between, so let's 0.15, 125 I think. I'm gonna duplicate this. Okay. And let's add some another interesting structure in between them. Okay, cool. So let's take this again and let's divide it. I'm gonna take on brick. I don't need this. Okay, and then I'm going to divide this geometry again. So divide node. Okay, and I'm going to use an expand 2D node. Set it to offset surface, and it's going to create that. 0.05. Okay, cool. Let's extrude it. Give it some thickness. And let's move it so it's in the right location. Cool. I'm gonna make another copy. I'll just move this guy. Cool. So this is our geometry, and we can add something else to close it so we don't see anything. But I'm not going to worry too much about this for now. Let's actually try. Yeah, I'm going to copy this. And I'm going to transform it. I want the pattern to be different. So let's try -1, yep, and let's do this. Cool, so we have one that is going in that direction and another one in the opposite direction. So this is basically the main concept behind destruction or modeling for destruction. And again, depends on the material that you have, depends on the internal structure that you have. You need to model all this. Now, why is this important? Well, let me show you. Obviously, I'm sure you guys got the idea already. So I'm going to create a VDB from Polygon, and I will show you the Voronoi node. So the best way to fracture a geometry, forget about this for a second. The best way to fracture a geometry is using the Voronoi algorithm. And I'm gonna the Voronoi requires an input geometry and a set of points. So I converted this geometry into points, into a fog volume, and I'm gonna scatter some points in there so that they are inside the volume, not just on the surface. Okay, so we have points in there, and then I'm gonna use a Voronoi fracture. Connect the first input and then the required points for Voronoi cell. This is what the Voronoi algorithm is going to use. Now it looks exactly the same, but if we hit the W key, you see it's fractured, and it has interior details as well. You can tick on visualize pieces, and this will show you what it did to the geometry. Cool. Let's turn this off and let's run the same operation. I'm going to use the same points here. Let's do an object merge and let's copy this and this, and I want to fracture this result instead. Let's make sure the points are in the correct space, so we'll have to move them a bit. Okay, and let's connect this now. Take a look. Let's click on, visualize pieces. Cool. And what we can do is we can delete a portion of the geometry, or let's use the exploded view. This node pushes the pieces into based on a interesting vector that is the centroid of the mesh. This way it shows you everything that you have internally, and you can see we have a lot of pieces. Now if we compare this with the other result, see it's very basic and it's not gonna look interesting when we destroy this. Cool. So let's take a look at let's do a quick RBD sim. I'm going to call this out RBD, and I'm going to create a dot network. I'm going to call this bullet RBD. Let's dive inside, and what we need to do is we need to create the bullet solver, and then the geometry type we're going to connect here, which is a RBD packed object, and then we're going to create a ground and gravity and a merge node. Let's connect this, this, and this. Okay, and let's browse for the geometry, which is connected in the out RBD, and let's hit play. Now nothing happens if we click here to show us the error. No, it did not. Well, the reason for this, could it be, let's add some velocity here. I don't think it's working. Yeah, so what's happening is this data is not packed yet, and what we need to do is we need to use an assemble node to convert this geometry into packed primitives. And the packed primitives needs one attribute for it to work properly in destruction and to be able to use the mesh correctly. We need to create a name attribute, which is a unique value per piece. Houdini will figure out which polygons are combined together to form a piece, and then it will create a name attribute based on that. So if we take a look at the primitive, you see we have, what happened? Anyway, if we middle click here, there's a name attribute, and that tells Houdini how the pieces or the primitives are connected together. The next thing, we need to tick on create packed geometry. If we middle click now, we see we have 1,000 packed fragments. Now let's go back to this. Let's hit play. It's pushing. It has a velocity of 10, so the pieces are going up, and then they're gonna fall down and smash. And that's our first RBD sim created. Cool. As you can see, everything is just falling down. There is no connectivity or resistance or anything. Let's give it an angular velocity of 5. And everything just falls. So this is where the constraint network comes in. It is needed for Houdini to hold and know how to hold the pieces together, and then the constraints will break based on either impact or something that we we create ourselves. Cool. Thank you guys for watching, and see you in the next video. Bye bye.